Thanks goes to Bitlayer for inviting me here for this great view. And it's one of the, I'm kind of weird guy. I probably enjoy more technical talk than some fancy cocktail parties. So I hope we can have some brainstorms and have some cool tech coming out of this talk. All right. So for me, I'm Xiaohui, and founder of this company called sCrypt. So sCrypt, you can think about it's a dev platform, but for Bitcoin-like chains. BTC, BCH, Bitcoin SV, and lately we have been working with some layer 2s like Fractal Bitcoin. And today, I think I'm talking about my favorite topic recently called OPCAT, and what are the apps that can be enabled by OPCAT. Just want to get a sense. How many people heard of OPCAT? Raise your hand. Wow, cool. Okay. Well, very technical audience. We have a technical audience today, because most people have not heard about it. And the community, I think, since earlier, I think either late last year or early this year, especially in the BTC community, there's a lot of discussion about, hey, should we do OPCAT? When do we do OPCAT? And I just want to give you a sense, hey, what this is hype is about, is it really hyped, or is there something really cool under using this concept? So I want to make this interactive, so if any other questions, just raise your hand, we can talk. All right. So I think, before even dive into the specific OPCAT, I just want to, give a very, let's say, very high-level overview. Where does the whole thing come from? Okay, so here I show a quote from the, none other than Satoshi Nakamoto. So he wrote this, I think, in 2009 or 10 in the bitcointalk.org. Basically says, hey, when I design Bitcoin, I want to be future-proof because I don't know what kind of use cases people will come up. I have this, so-called pay-to-script hash, pay-to-public hash and so-called Bitcoin address. But he was expecting people have more, let's say, complex types of transactions. For example, multi-sig, right? Or, arbitration, or escrow, all kinds of different use cases he wants to enable. He wants people to use. So for that to happen, he has two choices, right? One, he assumes he knows all the use cases, and then he hardcodes all of them in the Bitcoin client, right? That's one way. But then it's not future-proof, right? Because he didn't, as genius as he is, he couldn't imagine all the different use cases we have today, right? So the way he handled this case is, hey, I'm going to put this so-called Bitcoin script inside it. So it doesn't matter what kind of so-called conditions you want to program, you have this option, right? So in today's late world, it's called, smart contract. I would call it a Bitcoin smart contract. It has this like a virtual machine, which I call it a Bitcoin virtual machine, and it has the instruction sets called opcode. And one of the opcode is OPCAT. Okay. So just this diagram, I want to give you a very high, let's say, level sense of what I mean by Bitcoin smart contract, because most people, even if they're within the Bitcoin so-called ecosystem or community, they probably don't think, hey, Bitcoin, maybe you can do payment or stock value or maybe tokens, right? But then smart contract, usually people don't associate with Bitcoin. Okay. Hopefully, if there's one message I get conveyed today, hey, Bitcoin can also do smart contract. Actually, it can do arbitrarily complex smart contract. So you probably heard about, if you're in Bitcoin world, you probably heard about this model so-called UTXO, short for unspent transaction output. So as we all know, in Bitcoin wallet, if you have some balance, it's not necessarily in one transaction output. It could be in multiple. And the wallet will just aggregate all of them. And if you look at the simplest diagram, we have two transactions here. On the left, you have each transaction. In simplified view, right? You have input and you have output, okay? So on the left, you have the output, which is called UTXO here. And then when you want to spend it, you need to have some kind of like almost like access control, right? Because if anybody can spend anybody else's UTXO, the whole thing breaks down. It's like I have my own money, but you other people are not supposed to spend it, right? So in a logical sense, you can think about, hey, every output has some Bitcoins, and that's a lock on it. It's locked up. And then when you want to spend it, you have to provide so-called a key, almost like a key. And only if the key matches the lock can this unlock. You are authorized, and then you can spend the coins inside it. Right? So, and another way to interpret this is, think about the log as almost like a mathematical function. Okay, let's say, square root or like a quadratic. It's just a math function, and then in the input, you give it. Okay, so in the input, which is the key, you are providing a so-called waitlist, right? And then you apply this function on top of the waitlist or input parameter arguments. So if it returns true, that means you are allowed to spend. Otherwise, you cannot. So that's the simplest way to understand it. So when we have, actually, anybody here has ever sent any Bitcoin? Anybody? You have received, anyone owns Bitcoin here? Owns Bitcoin? Okay, cool. And anybody has used Bitcoin smart contract before? Actually, if you have Bitcoin, you already use Bitcoin smart contract, because usually the log is just check, hey, whether you have some private key for for your public key, okay, or public hash, which is address. So you are already, if you ever use Bitcoin, you are actually already use one type of Bitcoin smart contract. But here's the thing, that's not the Bitcoin smart contract that can be arbitrarily complex. It doesn't have to be only check signatures, right? For example, you probably heard about, time lock, right? So instead of requiring some signature, you can require, hey, I cannot spend it before 2028. You can lock it up. Or you can have some kind of almost like a passcode, so-called hash lock. Right? You can also say, hey, I don't need a signature, but I need to have some kind of like a value that hashes to a given value. Only under that condition you can spend. Or you can even have a multi-sig, right? Hey, only 3 out of 5 people can sign, and then you can move the coins, right? So this is a very, let's say, primitive type of a contract, but it is definitely doable, and it's even doable on Bitcoin mainnet today. Okay. So just give you a sense, I think this is I think maybe a couple weeks ago, somebody put this diagram on Twitter. So basically, it's it's similar as the almost like the chemical periodic elements table. So instead of putting each element like oxygen or carbon, you put the different opcodes. So previously I talked about Bitcoin has this like a virtual machine, and it runs the so-called the instruction set is just different opcodes, but Bitcoin script. So this, somebody just put this in a very nice, I think, diagram. You can see it has about almost like 100-ish opcodes. And for example, you can do a hash, right? SHA-1, SHA-256, or you can do add 2 numbers. Of course, we have the famous or infamous OPCAT somewhere. Okay. So basically, these are the basic instruction set, so-called opcode. And when Bitcoin first launches, it has all the opcodes here, okay, listed over here. And then some of history. So in the first 2 years of Bitcoin, for various reasons, I think a large case has to do with the securities. The creator, Satoshi Nakamoto, he disabled some of the opcodes. Most notably, you cannot do concatenation. Right? But he also disabled some other like arithmetic or bit operations like left shift, right shift, even disable multiplication. So shockingly, you cannot even multiply two numbers in Bitcoin script. And later on, there's some modifications. For example, you have some new opcode, For example, check log time, verify basically it's a log time opcode. You can log up some coins up to some either time or a block height, okay? And also some other upgrade, okay? So basically this is history. The most important message for today is this OPCAT was there in the first version, but later on for various reasons, it has been, I think, temporarily disabled. Okay. And then we're plugging a little bit of what we do here, okay? So we talk about Bitcoin script, right? And how many people are developers here? Developers? Developers here? Okay. Developers? Okay. So anybody coding, let's say, Ethereum? Anyone coding Ethereum before? Okay. So I'm not going to, do a survey, but if I have to guess, you're probably using something like Solidity, right? So Solidity is for people who do not know, is Ethereum. They have the so-called virtual machine called Ethereum virtual machine. It also has a bunch of opcode, and you can add numbers, you can subtract numbers. In theory, you can use opcodes to directly program Ethereum smart contract, but most people don't because it's just too complicated. Right? It's almost like assembly language. You are not going to program. It's going to be very, very difficult. So we are the same thing here. So think about sCrypt, the language. It's like Solidity, but it's instead of program Ethereum virtual machine, you program the Bitcoin virtual machine. Okay. So the good thing about sCrypt is you don't have to know anything about the opcodes because that's just too complicated and error prone. Everything is just super complicated to program. So that's why we come up with the idea. sCrypt is a high-level language. Actually, it's just a type. You can think about it as a library in JavaScript. Okay. More precisely, TypeScript. But you can think about, you can now program a Bitcoin smart contract with JavaScript-like language. So the benefit is you don't have to know about anything about OPCAT or OPAD, anything you don't have to know. We handle this job automatically. Basically, we have a compiler that takes the TypeScript code, compile it down to Bitcoin script. Okay, so you don't have to know anything about the underlying opcode like OPCAT. Okay. So here I list let's say the simplest TypeScript or sCrypt smart contract. Okay, so anybody has a guess what this contract does? Anyone? Just have a random guess. Yeah. So actually, it is everybody, whoever has Bitcoin has used this contract. Okay, that's a hint. Anyone have a guess?
Transaction.
Okay.
Spending Bitcoin, spending UTXO.
Okay, yeah. So basically, this does, as the name suggests, when we spend, if you have some coins in your address, and then when you spend it, you are actually running this smart contract called the pay to public key hash. Public hash is pretty much your address. So it checks two things. When you want to unlock it, you need pass two things. First, signature, and the second, public key. So what the Bitcoin miners do, or the virtual machine checks, whether the public key hash is checked, whether it matches your address, right, which is the hash of the public key. The second, if that matches, that's the signature check. You actually have the private key corresponding to the public key. Okay. So if both checks good, now this runs successfully, and then you are allowed to spend the coins. Okay. So just give you a sense, why we prefer to use sCrypt instead of just native Bitcoin script. Okay. So I assume a lot of people heard about this project. Anybody heard about the BitVM? BitVM? Oh, wow. We have a very technical audience today. Okay, so for people who have not heard about the Bitcoin VM, is a way to do very complex smart contract, so-called Turing-complete smart contract on top of Bitcoin today without change anything about the Bitcoin protocol. You can actually do it, but of course, they have some kind of like a off-chain part, but this is the on-chain part, which is encoded in Bitcoin script. So as you can see, is even for me, I work with Bitcoin script since 2018. It's very, let's say, esoteric or even very weird. It's very difficult to write or reason about and test and debug and deploy. Basically, this is not something you want your developers to work on. Okay, you want your developer to have something like what's on the right. So basically, these two are functionally equivalent. Okay, but as you can probably see, what's on the right is much more friendly to developers. Right? It's same. It's the same concept pretty much. But then on the right, it's much easier for modern developers to you just use all your regular tools, IDE, npm package management, debugger, testing framework, everything. You just reuse your so-called Web2 framework. You don't have to learn anything about Bitcoin specific. Okay. So just give a sense, and then let's jump to finally we come to the OPCAT. Okay. So what is OPCAT? Anybody can you explain what is OPCAT?
OP code.
Okay, good. Right. What does it do? We have 100. We have about 100 opcodes, right? So this is one of them. What does it do? Anybody know? Okay, so it is, as the name suggests, is short for concatenation. Okay, let's say you have a word called. You have two words, right? One is 1, 2, 3. The other one is hello. You can concatenate them together, then that gives you 1, 2, 3 hello, right? So this may look very primitive or very, let's say, feel underwhelmed because it's just too simple and looks like it's not going to do much, right? But the amazing result, based on a lot of research we have done in the past year or so, and also based on our history of, Bitcoin scripts in the past 6 years, is actually turning so-called Bitcoin smart contract from so-called Turing incomplete. You just add this one simple opcode, it's actually become Turing complete. Okay. So anybody wants to just explain what Turing complete means? A little bit technical, but what does it mean? Anybody here heard about this term?
Turing complete?
Yes.
It's just the ability to express any kind of logic inside your code. Basically, you can use any form equivalence to express everything, every kind of logic.
Perfect. Yes. So in layman's term, basically you can code any program, any computer or any other blockchains can code. Whatever, let's say Ethereum smart contract can do, you can actually do it on Bitcoin with this simple opcode. Okay. Addition of this. Of course, you have some other opcodes you can combine with it. And because mostly people, even today, think about Bitcoin as smart contract. You can do something, but it's so-called incomplete, meaning the functionality is very limited. You can do just a few things, as I said before. You can check signatures, do hash lock, or maybe time lock. Maybe you can combine them with different logical operators, but that's it. If you want to do very sophisticated contract, that's just pretty impossible. Okay. With this simple addition, I wouldn't say addition because it was there before, and now it was disabled, but now you simply, re-enable it. Okay. So if you look at the code, it's actually less than 10 lines. How do you add it back to Bitcoin? You just, instead of comment, you uncomment. Okay. It's very simple change. I mean, in terms of the code changes. All right. So then you may ask, hey, why do you need this opcode? Okay. And I'm just going to talk a few use cases, I think, which is very interesting and hopefully give you a sense or maybe inspiration. Hey, maybe I can use this opcode and the newly programmability enabled by it to develop all kinds of apps. That's, let's say, impossible before. Okay. So how many people have heard about CAT 20 in the past week or so? CAT 20? CAT 20? Nobody? Okay. You guys heard about CAT 20? What is it?
Based on the OPCAT or sCrypt.
Okay. Yeah, exactly. So even for that, how many people heard about BRC20 or runes? So CAT20, as almost the name suggests, is a new token protocol. So for guys who have heard about the ordinals or BRC20 or runes or atomicals on Bitcoin, you can think about the CAT. CAT20 is a new token standard, token protocol that you can issue fungible tokens on Bitcoin if we have OPCAT. So this is something that you cannot do without OPCAT. Okay. So actually somebody launched this real code, on the left. It's very similar to the way you do like almost like a BRC like kind of a so-called open mint or fair launch. Somebody launched this on another layer 2 called Fractal Bitcoin, mostly developed with the Unisat team. So this is launched last week, I think about a week ago, and then since then, it has drawn like there's an explosion of new tokens deployed or minted on that fractal Bitcoin. Okay, so at one point, so for the one that's deployed for the first one, called CAT, it takes more than 4 million transactions to fully mint out, and is all full blocks for 3 days, 3 full days. Every block is full, and the fee from like version 0, it's like 1 set per VByte, to up to, I think the craziest amount I've seen is 7,000 or 8,000 sets VByte. Basically, it's almost like order again. Everybody try to mint this up. Okay. So this is just a very interesting use case because this enables something that's impossible, really impossible without OPCAT. Okay. So the interesting about this new, let's say, token standard or protocol, we have a very nice diagram here. So the number one feature is so-called miner validated. Okay. So in layman's terms, you probably heard about BRC20 or runes. All these existing tokens, they are so-called you need some kind of indexer, right? Because that's the miners, because they use some other opcodes. For example, BRC20, you have the envelope, right? It's like you're using the ordinal envelope. You're pretty much putting off false or if. You're not actually executing. It's just dump the data in some kind of envelope. Or even runes, right? You put in the so-called operator, another opcode. Basically, it's not executed. It's going to be ignored by the miners. So the miners, they don't understand anything about ordinals, BRC20, or runes. Versus this CAT, so-called CAT protocol, because everything is almost the same with ERC20, right? Because if you know anything about ERC20, all this logic and data is stored on Ethereum blockchain, and all the transfer or mint is all verified by Ethereum miners or validated proof of stake. But everything, the network, the miners, they are going to run the smart contract and control the rule set of the tokens. So because of that, it has quite a few nice features, because then you don't need indexers, right? The miners are pretty much all indexers. You don't need any third-party indexers. Again, it's also so-called UTXO based, and it's just a new way for you to enable all kinds of ways to issue tokens, because you have OPCAT. So for example, it has some nice features. For example, ordinals, right? So for people who've used ordinals or BRC20, sometimes, if some wallet or some web site is not careful enough, they may accidentally burn users, tokens, because they think it's just some regular UTXOs. They don't understand. Hey, maybe there's some assets in this UTXO. They may spend it as fee, or they may send it to somebody else accidentally. But because this is miner validated, so-called contra validated, that's impossible. You cannot burn it accidentally. Second, for example, who has ever minted, let's say open mint BRC20 or Rune? Anybody? Okay. Okay, what happens if you send more minting transaction, if all the supply is already consumed? What happens?
Lose your Bitcoin.
Yeah, you lost your Bitcoin, a precious Bitcoin, okay? Because the miners, they don't understand, it's already minted out. So especially when there's a very huge backlog in the mempool, right? So even though all the supplies are minted, the miners still can take your transaction, but you're not going to get any tokens in return. So that's a very bad user experience. Versus in this CAT protocol, you are guaranteed if your money is spent, your Bitcoin is spent, you are guaranteed 100% by the miners, you are going to get the tokens. Or if you don't get the tokens, you are guaranteed you are not going to waste your Bitcoin. Okay. This is just some very nice feature. And of course, you can have some other more advanced features. For example, in existing legacy tokens system, you cannot do a partial fill order. For example, if I have 100 dog, runes token, somebody wants a 30, that's no deal because you have to exactly match. So in this one, it's possible to do a partial refill order. So if you only sell 100 cats, somebody only interested in 45, hey, no problem, you can take this 45, and I have another 55 remaining. You can keep selling. You can even do all this in so-called DEX on chain. You don't need Magic Eden or Unisat Marketplace. You can actually do this on chain, just like what you can do on other so-called smart contract blockchains like Ethereum or Solana. Okay. The thing about with OPCAT, you can do all kinds of any Bitcoin so-called smart contract that other blockchains, Ethereum, can do. Okay. Any questions so far? Go ahead.
Yeah, so just for the CAT, so for example, I ran into this problem when minting an ordinal where you have two different wallet addresses. You have your Bitcoin address and you have your ordinal wallet address.
Yeah.
So would CAT be able to save in the event that you unfortunately put your Bitcoin address versus putting your ordinal address to where it could like save that transaction or not really?
Yeah, you can actually. So I think without getting into much technical details, but all your addresses you're going to receive, your let's say CAT tokens, is going to show up in the wallet as different addresses. So for example, one will be BC1P, I don't know, AB, and then it's impossible to use that address when you the UTXO is going to show up very differently from your regular Bitcoins. So you are very unlikely to confuse like one UTXO with another because the shape is very different. So I don't know, the UTXO, if it only has Bitcoin or some other, let's say, ordinals, with some CAT tokens UTXO, the UTXO is going to be very, very different. So you are very unlikely to mistake one for the other. I hope this helps. Okay. All right. Any other question? All right. Let's keep going. And so I think I just talked about one very interesting use case that just came up last week. Okay, so following that, I'm going to talk about more, let's say, legacy use case people have been proposing with OPCAT. First one, I think most people talk about with OPCAT is so-called a covenant. Okay. Covenant, anybody heard about it? You definitely know. Okay, covenant. Anybody else heard about covenant? Okay. Cool. What's this covenant? Anybody? What's covenant?
Smart contract on Bitcoin.
Okay. Yeah. So you think about it as one type of smart contract on Bitcoin that let you, let's say, constrains your outputs of the spending transaction, right? So usually, let's say I'm Alice, I send Bob some Bitcoin, then I have no control how Bob spends it, right? It's his home, it's his full control. But if you have a covenant, this type of contract, you can limit how Bob spends it. You can say, hey, Bob, you cannot send this Bitcoin. When you spend it, you can only spend to these two addresses. Or you can say, hey, you can only spend it to Charlie, or after this time. You can basically limit the ways he can spend it. Okay, the next receiver. Okay. So looks very, let's say, insignificant, but then once you have a cache, you can have this primitive let's say covenant. Another way to look at it is covenant is now you can introspect the current spending transaction, right? Because you have UTXO, now you're spending, and then with OPCAT, you can have covenant. The covenant will let you know what transaction you can inspect or the full transaction, pretty much inputs, outputs, log time, or even version. You can know, almost like we call it a script context. You can know the current context you are running under. So with this primitive, and then you can have more advanced versions. For example, you can so-called, recursive covenant. So what does this mean? So previously you can say, hey, Alice sent to Bob, and then Bob can only send to, some fixed address. Okay, and then think about you extend this, not only limiting the next transaction, and the next transaction is going to place the same constraint to the next transaction, and then keep going, right? So you're almost like repeating yourself, or enforce this covenant recursively. Okay. So what's the implication here? That means we now have a way to add state into Bitcoin transactions. So for people who heard about Ethereum, right? Well, it's here, Ethereum is a state machine. You have a state S, and then you send another transaction, you transition to a new state S prime. Right? That's what the basic level what the Ethereum smart contract does. It has a global state. Every time you take a new transaction, you transition to the next new state. Okay, and then another one state come in, and another transaction you go to the next state. Just keep going. Okay. So in Bitcoin, because so-called UTXO model, if you don't do anything specific, you spend the UTXO, and it can become from unspent to spent, right? Because it's destroyed. Once you spend your coins, the UTXO is not there. Okay. So intuitively, that means the Bitcoin contract are so-called stateless. You cannot remember what happened before, simply put. But a lot of applications you want to remember, right? For example, you have a voting contract. You want to remember, how many people have voted and who's voting for what, right? Or even have let's say a layer 2 bridge contract. You want to say, Alice has deposited 2 Bitcoin, Bob has deposited 5, and then later on Charlie withdraw 3, right? So you want to remember the past, okay? And thankfully, because of OPCAT, you have covenant, and then you do a recursive covenant. Now you can add state. The Bitcoin smart contract now has memory. You can remember what happened before, and that's very, very useful. Okay, so in the simplest case here, I think Andrew you probably recognize this diagram. Okay, so let's say you have a vault. Okay, and we'll cover vault next, but let's say we have a counter example. Okay, so when you deploy a contract, you initially set a counter. It's a state. The state is counter. It just says how many times I have been called. Okay, meaning, which each time when you spend the previous transaction, you are essentially calling the contract on chain, and then you are updating the state, to a new state. So for example, in the simplest case, you can go from 0, and then you spend it. You have to increment by exactly 1. So it goes to 1, and then next going to 2. So you have a way now, just with this slight modification called OPCAT, you can now add states into Bitcoin contract. And if you think about Ethereum is pretty much just a state machine. And that is simplest explanation why it's only OPCAT Bitcoin smart contract transitions from so-called Turing incomplete to Bitcoin contract becoming Turing complete, because you can do anything that Ethereum contracts can do. Okay, at least in theory. We're not talking about performance or size of transactions or block size limit, but in theory, you can do anything that Ethereum blockchain can run. Okay. All right. Go ahead.
So will the BTC wallet notice this covenant? Because if the wallet is not notice that, then there will be fake payment.
I think that's an interesting question. So for Bitcoin wallet, most wallets today, they don't recognize this.
So if we somehow supporting this, then I can make false payments or fake payments that cannot stand?
Not really. So think about the analogy is on Ethereum, right? You can use Ethereum for two types of things. One is you can use it for payment. I just send you some ethers, right? Or I can use Ethereum to run smart contract. So the wallet usually just by default they only can recognize the payment type of contract, which is paid to public hash or paid to Taproot, right? You cannot recognize so-called more complicated smart contract. So default wallet cannot recognize.
So for
It
example,
doesn't even track them.
So for example, if I send you a transaction with the cabinet, but what will be the balance on your BTC wallet?
Basically depends on whatever this is. So the contract only, so in output there are two parts, right?
Yeah.
First is the amount, the balance.
Yeah.
Second is the contract.
Yeah.
That all depends on how much balance you put it there in the user. This which is decoupled from what is the logic inside the contract. Does this make sense? It can be 0, it can be 1, it can be 546. And when you say send to somebody, that implies the contract can only be unlocked by the recipient. If it's just a counter, you send money in, and then everybody can this is like open, and anybody can call this contract and take the money out. So I wouldn't recommend you use this to pay somebody else, because you can just use the native address type of contract. Go ahead.
Is it when you're talking about you could do anything from Ethereum on this system?
Yeah.
The state is from UTXO transition to UTXO transition, is it not? So how
Yes.
can you represent an account-based model, or are you assuming there'll be a Bitcoin covenant bridge over to an account-based model to do anything Ethereum can do, like the AMS DAX, for example, shared account?
So think about, in Ethereum you have contract, right? Contract has state. That's what the contract address is. And then every time you interact with the contract, you're just updating the state, right? So same here, you have a contract, and then you have some state. And every time you send another transaction to call it, you update the state. The only difference, I would say, or the most obvious difference, this UTXO is going to change. It's not going to stay the same, because in Ethereum world, the contract address doesn't change after it's deployed.
So message.sender is basically UTXO.
Yeah, for now you have to, if you want to call the latest, you have to find what is the latest UTXO. All the previous are already spent. So you have to track. Think of almost like the address. It's evolving. It's not fixed. After you call it, it's going to update it. Make sense? Yeah, it's a difference. Okay. So I think I'll briefly talk about this. The Ethereum world, it's pretty much a global state, because now you can simulate with OPCAT. You can simulate state in Bitcoin smart contract. So you essentially you can do anything that so-called Ethereum smart contract can do, which I argue is so-called Turing complete. If you think Ethereum smart contract is Turing complete, now the Bitcoin smart contract can also be Turing complete with this simple change. Okay. And this is another use case. A lot of people talk about a vault. Okay. So Andrew, you probably know about vault. So how many people heard about this Bitcoin vault idea? Bitcoin vault. Okay. What is it?
You limit future usage of some block Bitcoin.
Yeah. So basically, with normal Bitcoin, you send it to someone, you lock up in using some private key. You just remember the private key. But what if somebody steal your Bitcoin? They steal your key and then they can send it, right? But the vault idea is, hey, if I put this, let's say my Bitcoin in some kind of a special contract called a vault, then when you want to move it, you have to wait for, let's say, some configurable hours, let's say 48 hours. And within this 2 days time, if you notice, if you, let's say, set up some kind of alert, and if somebody wants to unvault this, your Bitcoin, you're going to get an alert on your phone, and you want to verify, hey, is this me? If not, you can cancel the transaction. The Bitcoin can go to some other address. In that way, even your private key gets stolen, you still you have some reactive. You can have some reactive security. So which is very important, to secure your own, if you want to, self-custodial your own bitcoins, right? So basically, without getting too much detail, also you can write that in Bitcoin script, or you can use our tools, which is much more user-friendly. Okay. So another way OPCAT is going to enable use case is so-called Merrotree. Okay. So the Merrotree, instead, think about, it shows up everywhere in Bitcoin, right? For example, when you do Bitcoin mining, you have block headers, which is pretty much the Merrotree of all the transactions within that block, right? So let's just give you a very good summary. So, Merrotree, and one way you can do it on using Bitcoin script, which is very difficult, versus you can also use our tools to, for any kind of a modern developer, you probably should be very familiar. This is a very simple, maybe too primitive, but okay, I'll just give you another sense. Hey, all this, you talk about, Merrotree, or maybe you can do hash with some easy opcode, but what does this enable? It looks like a very primitive. But what if I want to do very, very complicated smart contract? What's the most I think the most complicated smart contract in the whole crypto space, I would argue, is zero-knowledge proof. Okay, very sophisticated type of cryptography, with some very, very, let's say, you almost have to be an expert in cryptography to understand the whole logic. Basically, the short answer is it's very complicated, but with OPCAT, people have programmed actually the most sophisticated smart contract today on Bitcoin with OPCAT, called zero-knowledge proof. You can basically verify any zero-knowledge proof within Bitcoin script if you have OPCAT. Okay, so once you have that, you can do a lot of application. Right? For any kind of zero-knowledge, for example, you can use it for scalability, so-called roll-up, which is the primary way Ethereum guys want to, scale their blockchain. So, how many people heard about Stackwell or Stacknet? Okay, what is it?
L2, that's a scaling Ethereum.
Yeah, it's one of the major players when you scale Ethereum. And we are fortunate to partner with them to bring the so-called ZK stack-based rollup, or running on Bitcoin, assuming we have OPCAT. Okay, so this is some being actively working on, and we are very fortunate to partner with them. Okay. So by the way, if you have guys want to, have, let's say, advanced Bitcoin script running on Bitcoin main chain, assuming we have OPCAT, so definitely we can talk afterwards. Okay. So this is just give you a sense, with just simple change of OPCAT, you can have the most complicated smart contract you can ever imagine, at least up to date, with zero-knowledge proof verification directly on Bitcoin layer 1. Okay. This of course, I'm just giving you more examples here, which I'm not going to cover in detail, but think about once you have this simple change, you can have, MMM, you can have stable, algorithmic stable coins, you can even have bridge. That's like a two-way back, without trusting any centralized operator. Because bridge, as long when you ever want to cross blockchain, this is one of the biggest issues facing the industry today. You can make it actually trustless, okay? And you can do trustless staking, trustless lending. You can even do you can do all kinds of things. At least people have been trying on other blockchains. You can do it actually on Bitcoin mainnet today. And I think the example, of course, is limited. Think about this almost like the primitive building block. Once you have this Lego block, you can, because it's composable, you can compose, you can assemble, or you can interconnect all your different apps fully on chain, on Bitcoin. Okay. All right, and lastly, this is our website, and if you're a developer or any kind of builder who wants to know more about what kind of things you can do with OPCAT, please join our Telegram. And I think we created this group like maybe 1 or 2 months ago. Now it has more than 1,200 people there, and it's mostly developers. So if you're want to develop anything or you want to track, hey, what kind of cool things people are building on, definitely join this group. And there's already some other, let's say, other Bitcoin layer 2s, most notably called Fractal Bitcoin, which we are actually, because they has opcode, OPCAT enabled, so we're actually running, a smart contract in production on that layer 2 today. So definitely check it out. I think a lot of discussions today. It's not theoretical only. It actually runs on, let's say Bitcoin adjacent blockchains already. So that's it. Thanks for today. I'll wait for any questions you have. Okay, thank you. Any questions?
Just one, any meme coins that is going to come on OPCAT?
Yeah, it's called CAT, This is the logo. Some people use this logo. It's an open mint, and it was crazy. Took 4.5 million transactions to mint out. People actually spend $10 million, real dollars of fractal Bitcoin to mint this thing out in 3 days, non-stop. So, yeah, this is one of the crazy meme coin. I wouldn't say it's a meme. It's just the first coin of such types using OPCAT. So a lot of people think it's going to be, I don't know, I think it's going to be very, it's like, they say it's going to be the next order. Okay, I don't know about that, but it's just from technical point of view, and truly enables application that's impossible before. This is just some testimony, but not just, this is not something theoretical or it's coming in 18 months. Actually deployed last week, and people, crazy about trying to bring stuff. No financial advice. This is the CAT. Okay, CAT. CAT is the future. All right. Anything else?
What do you think of the BitVM 2 papers which came recently? Do you see OPCAT going along with that?
Yeah, definitely. I think it's very interesting. Yeah, BitVM version 1, they use it's called a gate commitment. You use a NAND gates, but it's very complicated because it's like they're almost like running computers. You are dealing with the lowest level, which is gates. So it's very, theoretically it's very sound and interesting, but unfortunately, in practice, very difficult to work with. I think that's why they transition to Bitcoin V2, VM V2, which is a ZK based. And the unfortunate fact is, I think the current implementation using ZK Star, and it's like Zulu network, they implemented one version which is like 7 gigabytes of script. Okay, so if you compare to the block size of only 4 megabytes, it's also very, very difficult to use it in production. But if you have OPCAT, it's going to make the script much, much smaller. I think based on some preliminary results coming from out of a Slackware, you can reduce it to maybe like 4, maybe even within 4 megabytes. That means at least now you can fit it in a single block, which is make it not maybe production ready, but at least much more like. So basically, in short, OPCAT is going to make Bitcoin VM2 much more efficient, maybe 1,000 times or hundreds, at least hundreds of times more efficient. Yeah.
Ordinals, right, have been more focused on the Bitcoin ecosystem only. Not many have been trying to develop on bit layer or stacks or for that maybe L2. Okay. So what do you think, why is it that so not many?
Oh yeah, it's very hard to say. Okay, so I think there's one thing I can think of is a bridge, right? Because ordinals, whatever you say about it, you don't need a bridge to another blockchain, right? And stacks and I don't know, rootstock, it's a lot of other layer 2, you need a bridge, and a lot of people just don't like it or maybe feel it's dangerous to bridge the valuable assets. But coming back, we can come back to OPCAT. If you have OPCAT, you can make the bridge much more secure. For example, you can make it so-called trustless. That's the best type of bridge. You don't need to trust any kind of centralized party. Basically, you can transfer it because you can verify the assets of one blockchain. They can jump, almost like transition to another blockchain without any trust assumption. So that I hope that you can if you own any kind of layer 2, and if somehow you can take advantage of OPCAT to make the bridging process much more trustworthy, I think that can help that layer 2. Hope that helps.
Yeah.
Thank you. Any other questions? Yeah, go ahead, Andy.
How do you think of the interoperation between the cabinets?
Interoperation? What do you mean?
Yeah. One cabinet invoke another.
Oh, yeah. Okay. Yeah, very interesting idea. Basically, for people not heard, let me repeat. So basically, is it possible, or even how do you do? Let's say, you on Ethereum world, right? You deploy contract A, and then you can call contract A from contract B, right? But you can actually do this on Bitcoin too. So let's say you deploy some contract, and actually there's a way to, for other contracts, so-called covenant, to become aware of another contract. The way, I think, without getting much into the technical details, basically, when you deploy a contract, right? Let's say you can get this, you can know the so-called Taproot address, agree? Because this is address pretty much encodes the contracts, right? And then, how do you do it? You can remember Bitcoin transaction that can have multiple inputs, right? So in one input, let's say you are calling contract A, and then in contract B is in another input. So you can, in contract A, you can check, because you can have the covenant, right? You can read the other inputs, and it's also its own Taproot address. So you can verify, hey, my next input is actually calling contract A. So that's the basic idea. So you have two inputs, and each one calling a different, let's say, covenant. And because covenant, you can introspect the transaction. The next input, so you can be sure you're calling the right contract. So that's a high-level idea. Yeah. Does this make sense?
Yeah.
Okay. Anything else? All right. Thank you very much.
Okay. Thank you so much.